Ahoy, mateys! Mrs. Banky here. Getting ready to make a video screencast of how to make calculations using a spreadsheet. The spreadsheet that we're going to be using today is Google Sheets, and I will guide you through the steps. We will also be referring to the lab data that you collected when we burned our snacks and allowed the energy from the snacks to be transferred to the water in the calorimeter. So this is a calorimetry lesson and also a lesson in how to use spreadsheets to make calculations. This is a worthwhile skill. It's a life changer. It'll make the world a better place. It'll make your lives better, and you will be learning some really great skills that you can take with you forever. And I smile, but I really mean it. I really mean it. I'm not joking. This is really valuable. So as you can see on this spreadsheet right here, what I have done is I have entered the data from the lab. So we took initial masses of the snack system. We lit the snack on fire. After it was done burning, we found the final mass of the snack system. We also got the mass of the water each time, an initial water temperature, and a final water temperature. You may have more than 5 trials. You may have less than 5 trials. But however many trials you have is where you want to start with this spreadsheet today. So you all have a spreadsheet that has all of the same headings on the top. What you need to do now is put your trial numbers in, and I will show you a little trick. It's not a super time saver when you only have 5, but one of the things that you can do in a spreadsheet is save time. So here I've started a trend, the 1 and the 2. And I want this trend to continue. So I'm going to highlight the 2. This is my trend. And then I'm going to hover over the little square until a plus sign shows up. And I'm just going to drag it down, and you can see that the trend continues. So if you got 6 or 7 trials done, it could be an easy way for you to not have to type each of those numbers. So again, using spreadsheets for calculations and little tricks like this save time. So what you need to do right now is pause this screencast, and then I would like you to enter your data in, your initial snack system masses, your final snack system masses, the mass of your water, your initial water temperatures, and your final water temperatures. So go ahead and pause this right now so you can enter your data in. Okay, so if you're back, you must have entered your data in, and the first calculation we're going to do is in this spot right here, the mass of the snack burned. Now you started with a certain amount of snack in the snack system, and when you got the mass of it after the snack burned, the difference is the amount of snack that went away. It got converted to gases and released into our atmosphere. So it is going to be the initial mass minus the final mass. So when we're using a calculation, if you click in the box, anytime you want to do a calculation, you type in equals. So that means this is the start of a calculation. Now I want to take the initial mass minus the final mass. So the initial mass for the first measurement here for trial 1 is in cell B2. I can either type B2 or I can click B2. I made a mistake. Or I can click the B2. And I want to subtract, so I'm going to put a subtraction sign in there, and I want to subtract C2. And I hit enter. So the mass was calculated, and now I only have to do that one time because once again, I can have all of those calculations done very quickly by clicking on that cell, hovering over the little square, and dragging it down, and I have just calculated all of the masses of the snack that burned away. Okay, so the mass of the water was consistent. It's not going to be part of, it's not, I don't mean consistent, I mean that it's not going to be part of a calculation. So the next calculation that we have to do is to do the change in water temperature. And we want to take the final temperature minus the initial temperature because that will give us a positive number. So this calculation is just the same, and I want you to go ahead and give it a try. Again, we need to take the final temperature, so the content of cell G2, minus the initial water temperature. So you go ahead and give it a try and drag the calculation down so that it hits all of your trials, and when you're done, just come back and keep watching the video. Okay, I'm assuming that you got it done, and if you didn't get it done because you were confused, I will go through those steps again. The change in the water temperature is going to be the final temperature minus the initial temperature. So again, I want to start a calculation by writing equals, and I want the final temperature, I clicked that, minus the initial temperature. I'm hitting enter, and the temperature difference in this case is 8. I'm going to drag and copy. Now we measured all of our temperature measure readings out to the 10th place, and technically this should be 8.0, but spreadsheets don't really follow that formatting. If it's 8.0, it just automatically puts 8 in. Okay, the next thing that we have to look at is the specific heat of the water. So the equation that we use for calculating the amount of heat that's absorbed by the water is heat is equal to the mass of the water times the specific heat of the water times the temperature change. And the temperature change is, or the heat calculation is one that we can do because we have the mass of the water and we have the temperature change. So the specific heat of water is a number that stays the same all the time. In this case, it happens to be 1.00 calories per gram per degree Celsius. So that is a physical property of water, the specific heat value. So we're going to put our 1.00 in. Unfortunately, it just changes it to 1, and I'm going to copy it to all of it because water is the same. Alright, so the next thing we need to do is calculate the calories released by the burning snack, which equals the mass of the water times the specific heat of the water times the temperature change. Again, we're going to be using a calculation using the spreadsheet. The mass of the water times the specific heat of the water times the temperature change. So that equals the mass of the water, and you have to use the asterisk as the times, the mass of the water times the specific heat of the water, and I clicked on it and it showed up, times the temperature change. And I hit enter. So for my first trial, there were 796 calories released by the burning snack, and that heat was absorbed by the water in the calorimeter, or in the can. So once again, I can highlight, or I can click on this box. I can click on the box, hover over the little square, and carry all of those calculations down. I'm going to erase this, if I can find it. So to get that out of the way. So I just want to point out in each of these calculations, you can see the formula up here, E2 times I2 times H2. When you do highlighting and drag, or when you click and drag to have the calculation repeat itself, it automatically changes. So we're in row 3 now. You can see the formula is E3 times I3 times H3. And here, E4 times I4 times H4. So all of that automatically takes place. Now, the calories released by the snack are actually much larger or much smaller than the calories we're used to. When you read food labels and it says calories, it is in actuality a kilocalorie. So a kilocalorie is equivalent to 1,000 calories. So what I want us to do right now is I want us to convert the calories to kilocalories. And the way that we can do that is by dividing by 1,000. So again, another calculation equals my calories, which can be found in cell J2, divided by 1,000. And for this trial, you can see that 0.796 kilocalories of heat were released. This is the calorie we're familiar with. I'm going to hover and drag so I have the calculation for all of them. Now, some of the snacks that you burned were bigger than others. So if you look at this number, there was probably a much larger snack since it released more calories compared to this one. So we need to do a calculation of the number of calories per gram. And to do this, we need what's in this column right here, the mass of the snack burned. So the calories per gram of snack burned equals the kilocalories divided by the mass of the snack burned. So this is another calculation, equals, my kilocalories are in cell K2. I'm just going to type it this time instead of clicking on it. So K2 divided by the mass of the snack burned, which is in D2. K2 divided by D2. Enter, and that's what it equals. Again, I'm going to have that calculation done for me very, very quickly. So when these calculations get done, you can see that the digits past the decimal point are very significant. And in the same way that we use significant figures in calculations, we have to round this to two significant figures. This change in water temperature was 8.0, which had two significant figures. The calculation came from multiplying the specific heat, which is an accepted number, so we don't use sig figs with that, times the temperature change, times the mass of the water. And most masses here have either 3 or 4 sig figs. So the change in temperature most of the time is 2 sig figs, so we're just going to round this to 2 sig figs. So this rounds to 2.2, 2.1, 2.6, 3.4, and 2.5. All right. Now, the next thing that we're going to do is we're going to compare our experimental kilocalories per gram to the accepted value for your snack. What you need to do now is you need to find the nutrition information for your snack. Right down here in the snack nutrition information, you can click on it, and depending on the snack you had, will give you the information. For this trial, I used the Cheetos. So since I used the Cheetos, I am going to go back into the Calorimetry Calculations tab. And I forgot it already. Cheetos is 5.4 kilocalories per gram. 5.4. And it's the same accepted value for all of my Cheeto tries. To get a percent error, we need to take our accepted value minus our experimental value divided by our accepted value times 100. Once again, another calculation. This time we need to use parentheses so that the computer knows the correct order of operations. So to start a calculation, once again, equals. In parentheses, I'm going to put my accepted value, which is 5.4. It's in cell N2, minus my experimental value, which is in cell M2, end parentheses, divided by the accepted value, which is the value in cell N, times, which is the asterisk, 100 equals. You can see here we have a 59% error. And those numbers are quite high. Now these numbers are to be expected. One thing I'm going to do with all of your data is I'm going to see which snack results in the lowest percent errors, and I may just use that snack for the future. But I'm very curious to know that, so I have decided to have students do this percent error calculation just out of my own curiosity. I want to know which snack gives us the least percent error. We will talk more about percent error with this lab and where sources of error could have come. It's a very crude calorimetry setup, and by crude I don't mean rude. I mean just very not elementary, just very basic. So there are a lot of places where heat could have been lost. So when you're done with this is all that I need you to do today, and you've already shared this with me, so it will, when completed, I will give it a grade, and I hope that you found some value in it, and it might not be right now, but perhaps in your future when you may have to use spreadsheets to do some calculations for you. So these are the same equations that are used in Microsoft Excel, and it carries over to Google Sheets. So this is all we're going to do with this today. Thanks for watching. I hope you have a great rest of your day. Goodbye.